I'm not supposed to be biased, and I'm not really supposed to like have favorite things to do, but right now, the single best $100 I've ever spent in my entire life was to buy my son one of these. It's a Spark Fun Inventors Kit. It's an electronic kit that uses an Arduino programmable logic controller. And this kit, this box, if you have $100 to spend in your classroom, this is what you buy. Don't worry about any of the little robots. Don't worry about anything else. This kit is my favorite kit that we use. So this Arduino and a breadboard. It's extremely important that as we go through this with the kids, right part in the right place. We talk about the right tools for the job. We talk about those safety features. Electronics like this are no place for plug and play. If you don't know what it does, don't stick it in a hole, right? Because magic smoke is like really cool during robot season when we're trying and testing and all this stuff, and then all of a sudden we burn out a chip. You know, that's fun. But in this setting, it's not so fun. So the learning curve for this is really tough. Like right now, if I asked anyone in this room to build me a project with an Arduino from scratch, I doubt any of us could do it. Completely from scratch, with no code, no help, no nothing. I gave you a box of okay, so over there's a temperature probe and a flex sensor. You're going to be able to plug it in and make it work? All right. So the learning curve's pretty high, okay? But that's what I love about this activity is it has a guidebook, okay? Now, the guidebook doesn't break my rules of don't tell them what to do. But it gets us over the curve of putting the right part in the right place. And this guidebook steps you through. It tells you where to put things. It gives you sample code. But the coolest part about this whole system is that then it has different challenges inside the code to see if you can manipulate it and make it do different things. It's a really good introduction to this idea of what a programmable logic controller, microcontroller really is. For most kids, they'll do a couple of projects and then realize, oh man, I really like to make music. So they do this project and then they spend the rest of their time manipulating this project. They don't care about making the robot at the end because they like music. And that's the cool part about this is it opens up a whole world of what you can do with these types of machines. So these kits are $100. The book comes with the kit, everything that you need to make everything in the kit. But that's not the good part. The good part about it is all these Arduino things are open source. There are 1.5 million different projects that you can do with an Arduino. It's all online. People have made it, and you go and you find it, you manipulate it, you change it, you make it better, and then you share what you've done. That's the beauty of open source learning. And this is kind of one of the biggest open source communities is with these Arduinos. So this is a great opportunity to go through some basic interactions between the digital and physical world. And when we're looking at how important this stuff is, pop machines have these inside. New pop machines have even better things inside that text the driver to tell the driver we're out of Dr. Pepper, so bring extra. The pop machine does that. Not the janitor, not the athletic director, or whoever it is that manages your pop machines. Pop machines do it themselves now. Cars, toasters, doorbells, everything that you can think of are starting to have these controllers in them. And if our children don't know what they are, they're going to be lost in the careers. The programming, the coding, the logic. There are studies that show that the understanding of code is as important today as reading was in the 20s when it comes to the level of job that you can get. It's not, I don't have to be a novelist to, I can read, doesn't make me a novelist. I understand code doesn't mean I have to be a programmer. But the ability to interact and manipulate and understand the processes that go along with these machines is essential today, let alone when the kids that we have now are getting out into the real world. So for us, this lab is extremely important. We do ask with this lab that we pay attention to where we plug things in, and we have an emergency operation procedure planned out, which basically means what happens if you smell smoke? Unplug it. Great, that's your safety operation procedure, right? Understand what we need to do to continue to use these things safely, and we can go through that process. Any questions about the lab? Yes?
How would you compare that Arduino to the MakerSpace?
We'll bring a MakerSpace up in just a little bit. This is, the MakerSpace has an Arduino capability inside of it, but its main function is the simplified interface, where this one is much more of the, it's a more complicated interface, but also gives you more, this one has a lot more capabilities than even the Arduino on the MakerSpace.
Do you think it'd be good to start with the MakerSpace and then?
Grade level, I'd start MakerSpace, younger kids, 5th grade on up, I'd just jump right into these. In my opinion, I love the MakerSpace. We use them a lot, but this is my favorite thing. So that's why I'm biased.